Oh god, it's a cat. Yep, 0 is a person, 53 is probably pizza. Let's say we're interested in getting the dataset, all the images from the COCO dataset that have carrots. So, bunch of carrots, right? It's like way more carrots than it's like probably more carrot images than I've seen in my entire life, but you know, the COCO dataset's got like 1700 of them. Hey, what's up everybody, it's Ivan here, and in this video we're gonna learn how to work with the dataset when it comes to object detection and image segmentation, which is the COCO dataset or Common Object in Context dataset. So in this video we'll primarily focus on the object detection side of things, as I will show you how we can read the COCO dataset for the bounding boxes of its, wait for it, 120,000 labeled images, and how to read for their bounding boxes, and then I will also show you how you can convert those bounding boxes to the YOLOv3 format. So it's like if you wanna use it for some common purpose, like I will show you how to basically like read the bounding boxes, get their like coordinates and stuff, and then I'll also show you a specific use case of how you can convert those labels to YOLOv3 format and use it like for training. Yeah, so it's gonna be a lot of really cool stuff, and I hope you really enjoy this. Before we start, consider subscribing and smashing that like button, cause like to let me know that you're just as excited as I am about the videos. And yeah, let's dive right into it. So now let's talk a little bit about the dataset like itself. So this dataset is the one that's like most commonly used to evaluate and train different object detectors and segmentators. So like probably like the biggest advantage of this dataset like its sheer size, because when we're talking about like 220 something thousand images, we can really find some unlikely combinations of objects. You know, if say I go here for a zebra and for a cake, and we'll click the search button, like we'll find something for like zebras and cakes, and yeah, and for zebras there and cakes. So like this is a really diverse data set, which has got like, I don't know, let's try teddy bear and say goat. Wow, I'm actually pretty shocked it worked. But yeah, it just demonstrates like the sheer, I don't know, like scale of the dataset, like where we can have sheep and a teddy bear like in the same image. Okay, they're mostly stuffed animals here, but still pretty cool. So yeah, and here's like, it's an actual, oh my god. Here's like an actual sheep and a teddy bear in real life. So yeah, so this kind of to demonstrate like the power of this dataset, and say many object detectors were like trained on it, including like YOLOv3, which is like, you know, if you download the weights from like the official website, you can like, it'll be basically trained on this dataset. And yeah, if you want to like learn about YOLOv3, I have a series of videos on my channel about that also. So now that we, you know, kind of got the feel for the dataset, and you can like go here and check it out yourself. I'll leave all the links down in the description. So yeah, so now let's actually move on to the our Google Colab notebook, where we're actually gonna be doing our magic here. And of course what we're gonna start from is downloading the COCO dataset itself into the Colab notebook environment. And to do so, I basically, you know, grab the links from here of like the 2017 test images, and then train images, and then like their labels. So that's kind of where I grab the links. So it takes a while to download it, so I've like already run the notebook the part of the notebook where we like do all the downloading and stuff. So download all the parts of the dataset, unzip them, and here is the part which is like the way that I found to read this dataset. It's based on it's done with the help of the Glue1 library and based on this article, to which I'll leave the link in the description. So we'll use it to essentially prepare the dataset so that then we can go and use it in our endeavors, right? So we'll install the Glue1, we install MXNet, and so here we run the preparation of the dataset. And so here's like the first thing that we can kind of like run and actually get a glimpse of actually working with the dataset. So yeah, I'm saying the word dataset too much, I think. But when you're making a video about a dataset, there ain't no way around it, to my best information. So let's first of all check out the lengths of the trained dataset here. So trained dataset. Okay. So it's 117,000 images, so about 120k images that we have in our disposal. So now this piece of code allows us to essentially visualize an individual sample from those 117k images. So if we say here like 37,000 guy, and we visualize it, well, we'll find like this guy here. We can play around with it a little bit, and it's kind of like to make sure that we've like downloaded the images and their labels and that everything is working. So then here you can run these styles of code, and here's the code that that I wrote basically to demonstrate how to essentially draw out all the bounding boxes and class IDs with OpenCV, because once you can do something with OpenCV, you can pretty much transfer that knowledge to everything else. So that seemed like a good idea. So here we can run it and see what happens. So and here we essentially like just, grabbing the image, grabbing its bounding boxes and class IDs, convert the image to NumPy array, changing its color scheme from BGR to RGB, and essentially iterating over the class IDs. And so this part of code is basically based on how, if we can see here, I print the bounding boxes and the class IDs. So like first of all, yeah, it's working, and second of all, you can see kind of like the format that we're getting for each image. So it's like the arrays of the bounding boxes, and say each. So it's basically like pairs, right? So this set of bounding box coordinates corresponds to like this class ID, and so I basically like double them like that, so that the zeros class is a person, so like this person's got this set of bounding box coordinates, and it's got basically this class ID. So essentially in this code, what's happening is that we pair the bounding box coordinates and the class IDs. So it's basically what happens here, and we can also like play around with it, like say give it some like different value and visualize it. So let's check it out. Let's do that. Oh my god, it's a cat. What a cute cat. I'm a dog person, but I also pretty much like cats. Yep, 0 is a person, 53 is probably pizza, and now, the question kind of arises, well, I guess if we're working with this dataset, we can expect that, like, like what are like those indices, right? Like we want the person to be named as like person and not just some indices, and like the pizza to be named pizza, because it's kind of confusing, like what's this 39, what's this 53 type of index. And it all comes from, so basically like the COCO dataset has got 80 objects in its arsenal. So these 80 objects, so each index basically has its corresponding object. And here on GitHub, in this COCO.names file, the like numbering starts from 1, but it's in reality it starts like from 0 in the dataset. So for instance, this person guy will be like the 0th index, which will be basically person, right? So yep, it's gonna be person. And if we're looking at, say here 53 pizza, so the pizza will be likely 54, right? So that's kind of like how the indices, are combined. So we've got, an index for each object, and then it's got its corresponding name, which you can check out by, loading like the corresponding file and basically comparing them. So yeah, pretty straightforward stuff. So yeah, at this point, we've kind of learned how to read the COCO dataset and get all of the bounding boxes and images from it. But now let's move on to a pretty interesting use case. All right, so now that we've actually learned how to read this dataset for the bounding boxes and the class IDs, which kind of like the main purpose of what we've been doing here. But let's now talk about like why that could be useful. And I'm gonna like tell you a story. So when I was training my model to detect bus numbers, bus doors, and like buses themselves, I was getting data from like two sources at first, from the Google images and from the streets of my city, by basically taking the videos of buses at like bus stops and stuff, splitting them into frames and then labeling them. And well, and getting more data means better quality of the model, and getting like more of the quality data, yeah, it kind of pretty much always should lead to better performance of the model. So I started looking for like ways to basically get more bus images, right? So then I like kind of thought that, if YOLO version 3 was kind of like trained in part on the bus images from the COCO dataset, like what if I can scrap those images? And so, yeah, basically I got all the bus images, which was about like 4.5k bus images from COCO dataset, then labeled them for their bus numbers and bus doors, and thus was able to basically expand my dataset and tremendously improve the performance of the model, because it's we've basically seen here, it's like a really diverse dataset. And if you're interested in working with some of the classes here, have it made be cars or birds, people, I don't know, cakes, like being able to basically get the images that you want from this dataset can be really valuable. So yeah, so in this case, I want to use like a use case. Let's say we're interested in getting the dataset and getting like all of the images from the COCO dataset that have carrots. So yeah, carrots are awesome. I'm pretty much into carrots, so let's give it a try, right? So as you can see, the index of carrots, it will be 51 from here. So here's like basically the code that, so yeah, and we'll kind of like get into the code that will convert, that will basically pull out all the carrots from this dataset and convert them into the YOLO version 3 format. Or if you're interested in a different format, you can like easily modify all that. So yeah, so first of all, we'll make two directories for the bounding box and for images. And so here's basically how it's gonna go. So we iterate over the trained dataset and we check if 51, which is the index of carrots, is in the class IDs of a given image. And if it's there, then we're interested in this image. So we proceed to convert it to like the NumPy array, and then we'll start iterating over each basically individual class ID, right? And if its class ID is also a carrot, or again, like it's all really highly, like like you can adjust itself for your own needs. That's why I'm kind of maybe starting a bit from afar, so that you obviously might not want to get the entire freaking dataset of carrots, but you may be interested in like trucks and cars, so that you'd be able to adjust this code to serve your needs. So here then we'll iterate over each individual class IDs, and and we also check if the class ID is 51, which is carrot. We basically get it bounding box coordinates, and then we use this code to essentially convert it, this couple of functions here, to convert it to the YOLO version 3 format. So let's try to run it. So it'll start, going over like all of the images, and here we can see like once it went through the 1,000 images and found 10 carrot images, then it found like 23 carrot images by the time it went to like 2,000. And we're not gonna wait for the whole thing to finish, but we'll probably be finding like more and more carrot images, right? So yeah, actually we can like kind of go here right now and check how many carrot images there are. So carrots, search. So there's 1,764, so basically 1,700 carrot images. And but we can have this thing go all the way through, but for the purpose of this video, we'll basically stop it here. And so we went to basically 8,500 images and found 121 carrot images, which is awesome if you ask me, because carrots are amazing, right? And healthy and orange, So then let's zip the bounding boxes in the images that we've got here. Yep. And now let's actually download this archive and have it run on my PC to basically see if it's working. So let's download it. Okay. So now that we went ahead and downloaded our labeled zip archive from Google Colab with our labels and our images of beautiful carrots, we can basically load them into the labeling tool. But before we do that, just wanted to mention that if you're scrap like a bunch of images from the COCO dataset that you need to use, it may make more sense for you to like here we just got 121 carrot images, right? So but if you got like thousands of images of people or cars or all sorts of things, it makes sense to zip that archive and put it on your Google Drive so that you can basically then access it from your Google Colab notebook, or just download it to your local machine. But without so it'll basically feels like a better option because it's quicker to download files from Google Drive, and if you intend to use them also in Google Colab, like you can basically easily copy them from Google Drive to Google Colab. So if your zip archive is huge, consider copying it to your Google Drive. Also have a video on how to use Google Drive with Google Colab. You can also check it out. Now let's actually, so I've opened up the OpenLabeling Tool here, and it's in the fourth part of the YOLO version 3 series, so if you haven't checked it out, you can also check it out. I'll leave a link. It's an awesome tool built by Joao Cartucho. So we'll copy all the labels to the bbox.txt folder and all of the images to the images folder, just like that. And here I've also went ahead and added the class list carrots. So let's run this thing, and ta-da! We've got a bunch of carrots, right? It's like way more carrots than it's like probably more carrot images than I've seen in my entire life, but the COCO dataset's got like 1,700 of them. So like legit carrots. yeah, and so you can configure the code here to be essentially to say, you know, to have it look for a different class ID, you know, say chairs or skateboards or kites, right? And you can have like several. So for instance, if you modify this code to be like, I don't know, if class ID is 51 as in class IDs, you know, and 44 in class IDs. So the point here is that it's highly versatile, like it's highly adjustable, so that for your specific task, it should be pretty straightforward to kind of modify this code to look for the images that you want. And one more thing that I want to add, also that this can be used to say find like images with like nothing. And what I mean by that is when I was training my bus model, essentially I used this method to scrub the images of like the images where there were trucks, but where there were like no buses, so that the model could basically learn that what a bus is not by looking at like trucks. So there's a lot of creativity that can be applied here to improve the performances of your models. So yeah, I really hope that this video and this code helps you. I think we can wrap up this pretty cool video by looking at the carrots. Let me find cool carrot image. Yeah, that's a legit carrot image. So I really hope you enjoyed this video. Thumbs up if you did. Please consider subscribing to let me know that you guys are as excited as I am about making these videos. And if you want to support me, ways to do that are in the description below. Thank you so much for watching. I hope you are doing the best, and the code will be like on GitHub, and yeah, all the links will be in the description. And there's a lot of things that you say in the end of the video, but the most important ones, I hope you're doing the best. Thanks for watching. Bye.